This is my Enme351 final lab presentation. I made Snake through working with a series of buttons connected to Arduino, as well as there's a potentiometer on the board that will adjust the speed of the game. This is demonstrated on a motor pointing as to how easy and or hard the game might be. Additionally, there's a speaker attached, and through some fun code, I've made some noises for the game as well. Here's the game in action. Again, I'm going to be using these 4 buttons as directional inputs. So the snake moves along with each button I press. If I collect an apple here, if I can actually do it, makes a little beep and grows the snake. Additionally, there's a score counter down at the bottom to let you know how big your snake has gotten. Then, if you're to crash into a wall or back into the snake itself, there's a little death chime. Then it resets the game and you can change your speed. If I were to crank it up to extreme here, set the speed to 100, the snake will move a lot faster and it's a bit harder to control. I'm not very good at it. Moving on to the code, we have, starting with Arduino, the buttons are all connected to digital input pins, which are declared and read appropriately. Additionally, there's a lot of specifics in the code that will be given with comments if you want to check it out in the code submission. Essentially what it does is, this is the control here, a lot taken from Lab 6 regarding the servo motor movement. And I used the map function twice here, once to map it properly for the servo motor, and then once to map the value properly for our delay time, which will essentially here function as the speed of the snake, because each time this serial prints, the snake gets updated in processing. Then here we have our death noise. This is done with serial communication from processing back to Arduino. And so as you can see, if it sends back a code of 3, then we play this long death chime. And then we reset the code, reset the start variable, meaning that the start screen will pop back up. Additionally, if the code is 2, that's our code for the apple's been eaten, and it plays the first part of that little ba-doop, resets the code and sets apple to true. The reason I do this is because in order for this tone to play properly, there has to be some sort of delay here. But if I do that, there's a noticeable lapse in processing with the snake whenever you would hit an apple. To overcome that, I created an apple boolean that just gets turned true, and at the start of here, if apple is true, then it will play the second half of the tone, and there doesn't have to be any delays as the delay is worked in with the code. Over in processing, I had 4 tabs up here. So the first is the snake game itself. This does all the drawing, all the setup. It has a game board object associated with it. Game boards consist of a 2D array of tiles, one snake object, and an int. Essentially what it does is create, this is a constructor creating the empty board with just empty tiles and tells them their position. It makes a new apple, which is this new apple function down here, which uses random numbers provided by processing in order to place an apple in a spot that does not contain the snake. The snake itself is a linked list of tiles, each tile having a next tile functionality. And essentially, snake game reads in all the information from Arduino, draws the starting menu, draws the board on each loop of the draw function, and then decides which direction the snake is going based on the Arduino inputs, and calls the next state functions in the board. That updates the code. It lets it know if it has lost the game or eaten an apple, and it transmits the code with the myfort.write back to Arduino.